Welcome to World Academy. My name is Sushma and I'm dealing with the subject mathematics. So the concept we are learning today is relations and functions from the module 1. So let us see what is relations and functions. So as a name says the relation. So we already know what is the meaning. We know what is the meaning of relations, correct? So relation is nothing but a connection. So whatever the connection we have with the other person, so the connection we are having with our mother, with our father, with our neighbors. So relation is nothing but a connection, correct? So as a name suggests relation, it's nothing but a connection or an association we have with other person or an object, correct? So that is called relation. So what generally means in mathematics, let us see now. So in generally, it is association of an individual or object. So it is a connection or association of an individual with an object or to a person. So correct. So we'll be having a relation with a neighbor, relation with the mother. So it is an association of individual or object with other individual or object. Correct. So it is a connection or association. Correct. So that is the meaning of relation. So mathematically, the relation says, so this is in general words we can say the meaning of relation, correct? So in this chapter we have relations and functions. So let us see what is the relations in mathematics. And before relations and function, we need to learn a cross b. Can you make out this is not a into b? Generally you read that as a into b. So can you make out that we have, so this is nothing but A cross B. So we read that as A cross B. Whatever the into mark we have, we read that as A cross B or B cross A. So that is nothing but a cross. So this symbol we read that as cross. So this is A cross B and this is nothing but Cartesian product. So what is this A cross B? Cartesian product. That means you got to know before studying about relations or functions, and before getting know about relations and functions, we need to know about the concept, the Cartesian product, that is nothing but A cross B, B cross C. So correct. So the thing we need to know about Cartesian product first before knowing relations and functions. Correct. So let us see about Cartesian product first. So let us see the definition of Cartesian product first. So if A and B are two sets, so we will be having two sets, that is A and B. So in the set A, we have -1, +1 and 2. In set B, 1, 3, 4. That is what we have written here, correct? So let A and B are two sets. In set 1, -1, 1 and 2. And set B, 1, 3, 4. Correct? So what is the meaning of Cartesian product now? So then the Cartesian product of A and B is a set of all ordered pairs. So set of all ordered pairs. So you know what is the meaning of ordered pairs, correct? So 1, comma 3, 4, comma 5. We name that as, we call them as ordered pairs, correct? So one is from X coordinate and one from Y. So we call them as ordered pairs, correct? 1, comma 3, 4, comma 5, 7, comma 6, any. That means the first value is from X axis and the other from Y axis. So we call them as ordered pairs, correct? So the definition of Cartesian product is nothing but, so the set of all ordered pairs. So how many set we are getting? So overall set of ordered pairs, we're gonna tell that as Cartesian product. Are you getting overall ordered pairs? See, -1 I can write with a 1. Again -1 with 3. Again -1 with 4. Correct? And again we can relate +1 with 1. +1 with 3. +1, I mean 2 with 3. Correct? And next, so again we can relate 2 with 1, 2 with 3, 2 with 4. Correct? So these are the ordered pairs. So -1 with 1, -1 3, -1 with 4. Again +1 with 1, +1 with 3, +1 with 4, 2 with 1, 2 with 3, 2 with 4. So the overall set of the ordered pairs, we call them as the Cartesian product. So you got to know the definition of Cartesian product. Cartesian product is nothing but the set of all ordered pairs, we call that as Cartesian product. So the set of all Cartesian product is nothing but the set of all ordered pairs, correct? From the set A and B. Listen here, we have the set A and B. So that is nothing but A cross B. So the Cartesian product A cross B is different. Again, B cross A is different. So here we have written A cross B. So we are relating all the elements of A to B. 1 plus to 1. Like that, we are relating all the elements. Suppose we have B cross A, that means first you need to write the elements of B, 1, 3, 4, then relate to elements of set A. So now, it is element of set B, set A. So plus 1 with minus 1, 1, and again 2, like this. A cross B and B cross A are different. Please understand, A cross B means you are relating all the elements of A to B. B cross A is you are relating all the elements of B to A. B from A and A to B. A to B, B to A. Correct? So this is the definition of Cartesian product. So we can write in two ways, okay? The set we can write in two ways. One is set builder form and one is the roller form. So now we have written Cartesian product. Can you make out the Cartesian product? We have written in two ways. So this is set builder form. So and again this is our roster form. Correct. So same thing. Directly I have written the answers. That is minus 1 with 1, minus 1 comma 3, minus 1 with 4, plus 1 with 1, plus 1 with 3, plus 1 with 4, again plus 2, 1 with 2, 3, 4. Correct. So whatever the method, this is called roster form. So we can write sets in right. So and again this is set builder form. So x, y such that x belongs to capital A. So that means all the elements from x belongs to capital A and the elements from y belongs to capital B. So this is the definition of Cartesian product and we can write in two ways, a roster form and one is set builder form. Correct? So and again, remember A cross B is different, B cross A is different, C cross D is different, D cross C is different. So A cross B means we are relating all the elements from A to B. B cross A, we are relating elements from B to A. Correct? So that is the definition of Cartesian product. So now as we learned the definition of Cartesian product, so this is nothing but the set of all ordered pairs. Okay. So ordered pairs from A to B, that is nothing but A cross B. If you write all the ordered pairs from B cross A, so that is nothing but B to A. Correct? So that is about Cartesian product. Next, let us see the definition of relation. So the actual topic of the chapter, correct? The relations. Okay. So a relation R is a set of all ordered pairs. So it's a set of all ordered pairs. So relation is nothing but, so minus 1 is related to 1. So we relate the elements of set A to set B with an arrow mark. So if they are related with an arrow mark, we say the relations, the set are in relation. So see, minus 1 is related to 1. Again, plus also related to 1. 2 is related to 4. So we can tell is a set of ordered pairs. So relation is nothing but a set of odd pairs. So again we can tell relation is a subset of Cartesian product. Okay. So see, R is a subset of A cross B because these are already present in the A cross B, correct? So R is minus 1 to 1, 1 with related to 1, 2 with 4. So relation is nothing but whatever the elements are related, they are related by a arrow mark. So we tell that it is a relation. And again, the relation is related by some rules, okay? Some conditions or some set of conditions they have mentioned, okay? You will get to know that. So it's a set of ordered pairs. So this is a relation now. They are related by a arrow mark, minus 1 to 1, plus 1 to 1, 2 to 4. So we call them as a relation. So set relation R, you can write. And again, R is also subset of A cross B. Correct? Because in a Cartesian product, you will get all the terms. If I write what are the elements of A cross B, so you will get minus 1 with 1, minus 1 with 3, minus 1 with 4, plus 1 with 1, plus 1 3, plus 1 4. Correct. So this is my Cartesian product. That is A cross B. Correct. So in A cross B contains all the elements. Can you make out? A cross B contains all the elements, all the set of ordered pairs. So our relation, whatever the relation we got, they are present in the Cartesian product. Correct. So they are present. So minus 1 to 1, plus 1 to 1, 2 to 4. Whatever the relation we got, they are already present in the Cartesian product, correct? So we are telling relation, always a relation equal to or will always be a subset of A cross B. I mean, relation will be a subset or equal to Cartesian product. Please keep in mind. So relation will be a subset, or maybe equal to a Cartesian product. That means Cartesian product contains all the elements present, all the elements of a relation. So it contains, so we call relation subset. So relation is a subset of Cartesian product. Is that clear? So always the relations are we represent or denoted by, they are related by a arrow line, correct? So arrow figure, representation of relation of math. So we relate them in a relation of A to set B is expressed in different ways. So we can express them in roster form, again set builder form, and the next way is by arrow diagram. By arrow diagram, and again by graph also fine. So diagram. We learned the definition of relation. So the relation from the set, one set to other set, they are related by a arrow diagram. So they are related. If the elements of set A are related to B, we call them, they are a relation. And again, we can relate the elements. I mean, we can relate the set A and set B can be expressed in these three ways. Okay, we express a relation in three ways. So the first one is roster form, set builder form, and arrow diagram. So the relations can be expressed in roster form, builder form, and a arrow diagram. Okay. So roster form we already know. So roster form and a set builder. So roster form. Hmm. So now we have the city and state. Okay. So Chandigarh, so related, correct. Chandigarh, Haryana, Chandigarh, Punjab, and Kolkata to West Bengal. So what is the relation we are getting? Chandigarh with Haryana, comma Chandigarh with Punjab, and again Kolkata with West Bengal. So we got three set for a relation. So a relation is a capital of, so Chandigarh to Haryana relation and Chandigarh to Punjab. Next relation, Kolkata to West Bengal. So this is our relation, correct? So city, so Haga, Chandigarh, Kolkata, and Mumbai are the city. So this is nothing but set A, and this is nothing but set B. So set B we have all the state, and set A we have the city. Correct? So this is a relation, they are related. So we're gonna call this as a relation. Correct? And again, we can write the set in. So we already, this is written in a arrow diagram. We already told you that relations can be written in set builder form, roster form, and again a arrow diagram. This is already a arrow diagram. Correct? So let us write this in a set builder form. So let city denote C and state be yes. Okay. So in a set builder form, we can write that a relation R is equal to set of x comma y such that x belongs to capital C, y belongs to capital S. So this is our builder form. So this is set builder form. Again in the roster form. So this is our roster form. Correct. So this is arrow diagram. So relations be written or represent. Relations is represented from set A to set B. We can represent the relation in three ways. Understand the three ways. So the three ways are set builder roster form and again arrow diagram. So this is in roster form now. This is set builder form and this is arrow diagram. Correct. So this is about a relation definition and how do we represent a relation. So relations can be represented in ways, correct? And again, in graphical method also we can represent. Okay. In this chapter, mainly we're gonna learn about these three methods. Okay, that is roster form, set builder form, and again arrow diagram. So now, see. So again here, this relation, so I can tell. So R can also be defined. So they have defined. So R is equal to x comma y, x belongs to A and y belongs to B. And the condition they have given is x square will be equal to y. So this is the x elements and this is y element. X element if you, so the relation, the condition they have made is x square 1. So x element is minus 1. So minus 1 square will be plus 1. So minus 1 is equal to plus 1. Next, x values we have x is equal to 1. So 1 square is also 1, and again x is equal to 2. 2 square is 4. So minus 1 is to 1, plus 1 is also related to 1, plus 2 is related to 4. So what is the condition they have mentioned? X square is equal to 1. And again, this is our roster form. I mean, this is our set builder form. So this is our roster form. This is our arrow diagram, correct? So we can relate the elements of set A is related to set B by some conditions. Can you make out? They are given us some condition here. So the condition is x square will be equal to y. So when the elements are related with some condition, we're gonna call that as relation. So when the element of set or the elements of set A is related to set B with some condition, so they are related with some condition, then we're gonna call that as relations. Okay. So this is the definition of relations. So and they are related. So after that, so since we have seen the definition of relations and the representation of relations, so we have this types of relations. So we have four types of relations: one to one, to many to one, and many to many. These are the four types of relations: one to one function, one to many to one to many. I mean many to many. So these are the functions. So let's see one to many to one, and many to many functions. So let us see each functions. Okay, I mean relations. Let us see. So as the name says, one-to-one relation means when one element in the domain is not all the elements of X. See, suppose I have the ordered space 2, 4, 4, 2. The first element we're gonna call that as X. Right? So when one element in the domain, the first element, all the first element, we're gonna call them as domain. All the first element, we call them as domain. Remember that. So all the first element of the domain, that is nothing but X values. Okay, domain maps to one element, code element or range. So all the X elements, we call them as domain. All the Y elements, we call them as range. Okay. So now the definition one element of the domain is mapping to one element. So one element of the domain is mapping to one element of the codomain or range. So one is mapping to only one element. So all the elements are mapping to only one. So when we call them as one-to-one relation. So what is the meaning of one-to-one relation? When all the elements in the domain maps to one elements in the codomain or range, we call them as one-to-one. Okay. So this is about one. And one to many, when one element in the domain relates to more elements. When one element, so if it relate to one element is related to only elements from domain to codomain, we call them as one to one. If one element from the domain is connected to or related to more than two or more than two, we call them as one to many. So one to many. So this is one to many. One elements in the domain relates to two or more. So it is related to two elements here and again two elements. So we tell this as one to many. So one element in the domain, one element is related to two or more elements in the codomain. We call that as one to many relation. Okay. So next we have many to one. When two or more elements in the domain, so two or more elements, so two or more elements in the domain map to one element in the codomain. See, two or more elements. So one zero is also related to four, and four is also related to four. So two or more elements is related to one, only one. As the name says, many to one. So many are related to one. Okay. So many from the domain are related to only one, to in the codomain or range. Correct. So we call such type of relation as many to one. As the definition says, many elements. So many elements in the domain is related to only one element in the codomain or range. We call them as many to one. See, zero is also related to four. Four is also related to four. Again, one is related to one. Three is also related to one. Correct. So we call them as many to one relation. So many to one means two or more elements from set A, I mean domain, two or more elements from domain is related to only one element in the codomain. We call them as many to one. And next Many to many, as a name itself says, two or more elements in the domain relate to two or more elements. See, many to one, many to one, many two or more elements from the domain relates only one element in codomain. Many to many means many elements, two or more elements from relates to two or more elements in the codomain. So we call them as many to many relations. Okay. So you see, again, minus 2 is related to 0. 0 is also related to 2. So many elements is related to two or more elements in the codomain. So you can count 0 is also related to minus 2, 0 is also related to plus 2, correct? So many are related. So we call them as many to many. Okay. So we already learned the arrow diagram. So the arrow diagram. Again, graphically, we can write since we know to mark, right? Ordered pace. Minus 1 is from x-axis, plus 1 is from y-axis. Minus 1 to plus 1. So again, plus 1 to plus 1, 2 to 4. Correct? So this is represent graphically. This is 0, 1, 3, 4. So 1, 2, minus 1, minus 2. It will be plus 1, plus 2, plus 3, plus 4. Correct? So 2 to 4. So this is we represent ordered placing graphically. Graphical way you're familiar with graphical method, correct? So now let us see what's domain. So whatever the input, so whatever the x value. So see, we have the ordered pace 1 comma 1 minus 1 comma 1 2 comma 4. So all the first elements can you make out all the first elements nothing but x, correct? So x comma y, all the first elements we call them as input. So input all the first elements we call them as input or domain. So all the first elements of the ordered pair, I repeat, first elements of the ordered pair, we call them as domain or input. Okay, that is not a value. So that is the meaning of domain. Here the domain is minus 1, plus 1 and 2. Correct? So next we have the range. Range is nothing but output. See, output, whatever the x values, we call them as input. So that is nothing but domain. So all the y values, we call them as output. So all the y values is output, call that as range. So this is our range now. So this is our output, 1, 1. So 1, 4 are our output, correct? Understand, input is nothing but all the first elements of the ordered pair, that is nothing but x, and we call them as domain. All the second element, that is nothing but y, which is our output, we call that as range. So you got the idea of domain range now. So, and again a codomain. Codomain is nothing but all the element of set B, all the elements. See, if they are related only, we tell. See, here minus 1 is related to 1. So only 1 and 4 are range now. Understand? Only 1 and 4 are range. So all the elements of set B, I mean all the y values of the ordered pair, we call them as codomain. So codomain. Clear? So codomain notation is this image set 1, 3, 4. So all elements of set B, we call them as codomain. And again, range is subset or equal to codomain. So this is what we learned in today's class. So let us summarize what we have studied. So we started with the relations definitions. We have seen the relations. Correct? So relations, relation is not element of set A is related to set B with some condition. Correct? So again, we can write the relation in roster form, set builder form, and again arrow diagram and graphical representation. And we have seen the types of relations. So we have the types of relations are one-to-one relation, one-to-many. So this is one-to-many relation, many-to-many, and many-to-one. So these are the types of relations we have learned. As the name says, more elements from set A is related to only one element in the set B. Many to many, two or more elements from set A is related to two or more elements to set B. After that, we have seen about the uh, domain, range, and codomain. These three are very important. Domain is nothing but all the first element, correct? So all the first element is nothing but X, we call them as domain. So all the second element, we call them as range, and range is our output, domain is our input. And again, codomain is nothing but all the elements in set B, we call them as codomain. Okay. So these were the things we have learned in today's class. Thank you.